All right, so in this video, I'm going to do a type of homework question that can be a little confusing when it's asking you to determine whether or not a statement is called, quote, an implication. So let's first recall what an implication was. Okay, we use that in English a lot. We say, oh, that means this implies this, right? Now, an if-then statement typically seems like an implication, right? If someone says, if you do this, then this will be your outcome, it's saying that the first thing implies the second thing typically, right? But we have a formal definition. If you look in your notes from our class, we said an implication had to meet two qualifications. The first qualification that it had to meet was it had to be a conditional statement. So that's your first question. If you're looking for an implication, is this conditional? What do I mean by conditional? Do you remember? That's right. Is it an if-then? Right? Is it an if-then? So if blank, then blank, right? If-then. So here we ask ourselves first, is this a conditional statement? Can you answer that question for me? Are, arrow, not are. Good job. It is a conditional statement. So if you were wondering if this is conditional and you said, yes, I think it is, you are correct because it has the if-then. Okay. Second thing you have to ask yourself, is this conditional statement always true? Does are always imply not are? In order for it to always be true, remember what we called that? Starts with a T, it's not a trilogy. Tautology. Good job. You can look in your notes. Is this a tautology? Is it always true? Well, how do we determine that? Do you remember? Hint, hint, it's on my screen. You make a truth table. So one way that you can determine a tautology is to construct what we call a truth table. And how did we do that? Well, we had to ask ourselves, the original statement has how many original letters? In this case, you have an R and a not R, but notice those are the same letters. We've just negated it. So if it only has one letter, remember we say 2 to the n rows? So if n is 1, 2 to the 1 equals just 2, doesn't it? So notice I only needed a truth table with 2 rows. So what are your options for statement R? We don't know what statement R is. It could be I like chocolate. That statement could be either true or it could be false. So that statement R could either be green for true or red for false. Again, you don't have to color code things like your professor does. I'm a little over the top here, but I like to be simple for myself. Okay. What next? Well, now you need to actually write down the whole statement, right? The statement is are, then, not are. If are, then, not are. Negation of are. So we need what column? Which column do you think we need next? If you said negation of are, you are correct. So let's go ahead and put a negation of are column. So how do we negate something in a truth table? Do you remember? That's right. Every true becomes a false because they're the opposite, right? So the first true is now an F, and the second one, which was false, is now a truth, or a T. Okay. We're ready now for our entire statement. Let's write it out. The statement was, if are, then not are. If are, then not are. Okay. So we're going to look at the R because that comes as first as our antecedent. It comes before the arrow. Looking in that direction then, we're going to say R, then not R. Can you remember or remind me or remind yourself, since I can't hear you, can you remind yourself what is the only condition when an if-then or a conditional statement is false? What is the only time you can say someone lied to you if they said, if you do this, then I do this? That's correct. If the first statement is true, but the second statement is false, then we say that the whole statement is false because the condition is met, but the expectation or the promise is not delivered. Remember that? So let's see, does that ever happen here? Oh, it does. You're right. In the first case, true and then false is false. And in the second case, that would be a true statement in that situation because the condition was not met. It was false, so you can't call me a liar. If I say, if you clean your room, then you get an ice cream cone, and you didn't clean your room, do I owe you an ice cream cone? No, you can't call me a liar if you don't get an ice cream cone in that case because you didn't meet the condition that was set up. Okay, so in this situation, that's a truth. Okay, so the question now becomes, to answer the question finally, is this an implication? Well, you need to determine, is the statement itself a tautology? In other words, is it always true in every condition? That's what we mean by tautology. Is it always true? And what do you know? It is not always true because we had a falsehood. So since it's not always true, this is not a tautology. And if it's not a tautology, then it is not an implication. So what does that mean? That means, well, sometimes R implies not R, but not all the time. And to be a true implication, to be a real implication, that conditional statement must always be true. R must always force not R to happen, like a domino effect. And in this case, it does not, so we say this is not an implication. So once again, implication requires two components, a conditional statement, an if-then, one arrow, not two, and a tautology. In the truth table, it's always true. Well, I hope that helped. If you have any questions, feel free to email me. Otherwise, make sure you practice because math is not a spectator sport. I'll see you next time.